Hi, welcome back. Now we're going to go ahead and talk about something called intersection and union. And if you took algebra of any kind, you've probably have heard of both these words before. But now we're going to talk about them instead of how you talked about them in algebra in terms of kind of a graphing thing. We're going to talk about them in terms of sets, okay? And so the intersection of two sets A and B, okay, is written like this with an upside down U, B, okay? And these are in both A and B. And being a very key word here. Anytime you see the word and in a problem, that is always in here going to be an intersection, okay? When we're talking about union of sets A and B, we have A, union, now no little curly Q on the U, B. So these are things that can be in set A or set B, or both. I can't write today. The key word here being or. So when you see or, it is going to mean the union of two sets. Okay? So if I have, real quick, let's just make one up. I have set A. I don't know. 1, 2, 3, 4. And set B, that'd be 3, 4, 5, 6. Not being real entertaining here, okay? If I want A intersect B, or A and B, I want elements that are both in A and in B. So 3 and 4 are elements that are in both A and B. Okay, so they have to be in both. So I have 3 and 4. If I want A union B or A or B, right? These are cell elements that are both in A, in set B, or both, okay? So in this case, my union is going to be 1, 2, 3, 4, 5, and 6. I didn't have any extra elements that were just sitting out in the universe, okay? So it's really important that you also not only know the symbols and know what they mean, but also the wording behind it. Okay, because you're going to need that as we get more and more things going. All right. Another thing I want to talk about is with the empty set. Okay, remember our empty set? Okay, which is our 0 the slash or just an empty bracket. If I have any set A intersect the empty set, it is the empty set. If I have any set A union the empty set, it's going to equal A, which kind of makes sense because the only thing that the intersection is empty because there's nothing in there. This also, if I put them together, the empty set is empty, so all I have is set A. Okay, so make sure that you kind of remember these little rules for the empty set as we go on and look at our next example that I have. Okay, so this is both example 6 and example 8 on page 15. Okay, and I'm just putting them together. They're the same sets, but one's union and one's intersection. Okay, so I have a universe, goes from A to H. A is AGH, B is BGH, and C is CDEF, and that's it. Okay, no G. Okay, if I want A intersect B, A and B, I have to look at the elements that they only have in common. which would be right there. Okay. And so my set here would be G and H. If I want A union B, or A or B, right, this means I want to go ahead and put my two sets together. So I need all the elements from here and all the elements from here. So I'm going to have A, B, G, and H. So I need, they could be in A or in B or both. Okay, so I'm including all those. If they repeat, you don't need to write them twice. You only need to write them once. So you don't need to write the repeating G's and the repeating H's. If I want A intersect the empty set, we just talked about this. A intersect the empty set. Okay, this is going to give us the empty set. If I want A union the empty set, this is going to give me set A. So anything that's in set A. Okay, so A, G, oh, that's messy. Let's do better than that. Going to give me A, G, and H. Okay? If I want A intersect the universe, what do you think that's going to be? The universe is everything. All of this stuff. A is only a part, but everything in A is part of the universe, so this is going to be your elements of A. Okay. Now, what would you think it would be if it was A union the universe, which would look kind of weird? AUU. It's going to be the whole universe. So this is going to equal our universe. All right. So make sure that you know the difference between union and intersection, and also the difference between and or. All right. Another thing we want to look at here, this is an example that I have ready for you, is when we have more than one set operation. Okay, so when we have more than one set operation, let's say A union B, but on the outside there's a set of parentheses and complement. Okay, what we need here is we need to first do what's inside the parentheses. We need to do A union B first. Okay, and A union B in this case is going to be what? Okay, A union B is going to be everything in set A or in B or both. Okay, so this is going to be B, C, and E. That's what we're working with. But remember, we got to take the complement of this. So now we need A union B. So our values in blue. We got to take the complement of that. Okay. So things that are not here. Okay. So we have B, C, and E. And we need to pick the members of the universe that are not those. Okay, so I need A, I need D, and it looks like that's all I'm going to have that's left. Okay, so my A union B complement is just going to be A, D. Okay. Now, it does make a difference if there's a set of parentheses or not. So if I go ahead and take A complement intersect B complement, I need to find the complement of A, and my complement of A, things that are not in A, are A, D, and E. Still working with the same values. Then I need to look at my B complement. So what we have that are not in B. Okay, so B is B, C, E. The things that are not in B are A and D. In our last part of this, we need to find what is not in A, or A complement, or not in B. All right. So remember, the items that were not in A are A, D, and E. The things that are not in B are A and D. This is and, not or. So I need to find the things that are not in A and not in B. And these are the only things that match. So A complement intersect B complement is just going to be AD. Okay, so they have to be done separate. So whenever you see a parenthesis around the outside and then the complement, you have to do, just like order of operations, if you remember any of your algebra, where you had to do parentheses first, that is the same idea. Okay, so do your parentheses first, then take the complement. If there's no parentheses, you have to do the complements first and then do the and or the or. Okay? So let's look at different sets here. Okay, and this is example 11, right? And I drew it out for us. I'm not going to do all of them. There's like 5-6 parts, okay? But let's go ahead and determine each of the following sets just using this Venn diagram. So rather than given a roster, let's go ahead and look at the Venn diagram. A intersect B. Okay, A intersect B, going to be this region here. Okay, and what else? This is A or B. Or sorry, A and B. I'm losing it. Okay, and so we're looking for things that are in A and in B. In this case, this is going to be just the number 5. Right? If I have A union B, that means I want set A, set B, or both. Okay, so this one's going to be nice and long. It's going to be in set A, set B, or both. So I have 2, 3, 5, 7, 11, and 13. Okay. Oops. All right, so now I want to go ahead and look at A union B complement. Okay, so I already found A union B. A union B is everything in A, everything in B, or in both. So all that's left over is these two numbers from the universe, 17 and 19. The last one I'm going to do is A complement union B. Okay, so we're looking for the set of elements that are in A, but not in A, but in B or both. Okay, so A complement anything that's not in A. So 5, 7, 11, 13, 17, and 19. Don't forget the two pieces out in the universe. B, nice to kind of write it out. You don't necessarily have to. Is 5, 7, 11, and 13. And what's in A, what's in B, or both? This ends up being just our A complement. Okay, so our A complement union B is going to be 5, 6, or that's no 6. Caught myself. Be careful when they don't go in order. 5, 7, 11, 13, 17, and 19. Okay, so those are the items that you're going to deal with. Just be able to look at it and determine what the items are. Okay, so is it and, is it or? Okay, and complement, what is the complement you're looking for? Is it the whole thing? Is it just a piece of it? All right. The last idea in this section, okay, is looking for something called the cardinal number. Okay, the cardinal number, what it allows us to do is find the number of elements in the union of sets. Okay, so the number of elements in union sets. Okay, and these sets, of course, must be finite. There's going to be no infinity going on. Okay, and it's just a formula. Okay, so we want to look at the cardinal number of A union B. Remember, it has to be a union. And what this needs to be the do is we're looking at the n of A plus n of B minus A union B, or A intersect B. Going to learn to talk tonight. All right. And I'm actually probably going to do both of the examples for you, okay, to kind of help make this make a little bit of sense. So example 13, we have, there are word problems. We have, among U.S. presidents in the White House, 26 had dogs, 11 had cats, 9 had both. Okay, so they're giving us these things in words. Okay, so the number of elements in A, 26. I'm going to say dogs are element A. Plus the number of elements in B, for cats, is 11. Minus the number of A intersect B. Okay, so minus my 9. And when I go ahead and get that, I have the number 28. So you're just using the number values in the set. This tells me in the union, I should have 28 elements. Okay. If we look at example 14, it's very similar. Okay. Winter Resort took a poll of 350 visitors to see what they like. So there's a total of 350. Okay. In other problems that will mean something for us right now, it really doesn't. We have 178 people that like to ski. I have 154 that like to snowboard. I've only gotten to snowboard, I've never gotten to ski. And 49 likes both. So again, we're going to use the same formula. I'm going to have my number in set A, 178, plus my number in set B, 154, minus the elements that do both, 49, and I end up with 283 people. Okay, so that completes section 2.3. Go ahead and get started on the homework. If you have any questions, feel free to go ahead and ring me up, and I'll see you for 2.4.